This is part 2 of your chapter P notes. The first thing in this section is scientific notation. I'm sure most of you have seen this one before as well, but scientific notation pretty much means you have some digit that's not 0, and then a decimal, and then some more digits, but then it's times 10 to some number. So the key is this number can only be one digit and it cannot be 0. It can be negative, that's okay, but this would be considered scientific notation. So this particular number is in scientific notation, and what we want to do is to put it into standard notation. That means without the times 10 to the 7th. So if you see this is a positive number, you could put this in your calculator, or you can just say 963, that's these 3 digits without the decimal. This means move the decimal that many places and make this number big. That's positive, so you make it big. So here's where it was, so that's 1, 2, 3, 4, 5, 6, 7. Go back and put in your commas, and this is in standard, oops, can't draw a straight line. This is in standard notation. So if this number is negative, what you want to do is make this number smaller. So we have our 2, 3, this is where the decimal was. We move it back 6 places. 1, 2, 3, 4, 5, 6. A lot of times you want to put that extra 0 in front of the decimal just to make it look better. So this one is now in standard notation. So what if you want to multiply numbers that are in scientific notation? All you have to do is multiply these parts, then multiply the powers of 10, and then you want to make sure that you go back and put it in scientific notation. So 4 times 5 is 20. Then you have 10 to the 13th times 10 to the negative 9th. Remember, when you multiply like bases, you add the exponents. So what's 13 plus the negative 9? That would be positive 4. This is not in scientific notation because these are 2 digits in front of the decimal. So here's the key. If you're making this number smaller by 1 place, you have to make this one larger by 1 place to make up for it. So you get 2 or 2.0 times 10 to the 5th power. This is now in scientific notation. So over here we're dividing numbers that are in scientific notation. You do the same thing. What is 1.2 divided by 4? That's going to be 0.3 or 0.3. Whenever you divide like bases, you subtract the exponents. That's negative 9 minus a negative 7. Remember, minus negative is plus positive, so negative 9 plus 7 will be negative 2. So this is also not in scientific notation because this is a 0. We have to move this decimal 1 place this way. That's making the number bigger. So we have to make this number smaller by 1 place to make up for it. So we end up with 3 or 3.0 times 10 to the negative 2 minus 1 would be negative 3. Now for the good stuff. Rational exponents and radicals. This x to the m, I guess that should be an x, not an a right there. X to the m is here, x to the m. This nth root is denoted by the denominator of the fraction. So the nth root of x to the m is equal to x to the m over n. This is your power or your exponent, or call it the power. And this is the index on the radical. This little number on the outside is called the index. Okay? I know all of you know how to do the square root of 36 is just 6, and that's because 6 squared is equal to 36. Okay? We know this already. But what if we didn't know that? I'm going to teach you something called the prison method. It's kind of morbid, but it's really cool how it works. Write down the prime factorization of 36. Well, we know that's 6 times 6. You could use any two numbers, 2 and 18, 3 and 12, as long as they multiply to give you 36. You keep going until everything is a prime factor. 6 is 2 times 3. So now what we have is 2 times 2 times 3 times 3. Since this is a square root, that means the index is an invisible 2, you want to pair these. Put them into pairs. There are 2 2's and there are 2 3's, so both of those get in a pair. Now remember, those are under a square root. 2 times 2 times 3 times 3 is 36. Okay, this square root is the prison, and all these little guys, those are the prisoners. They want to escape prison, but the index tells them how many have to be in a group to escape prison. The cool thing is, everybody gets to escape. The bad thing is, only one in each group will survive on the outside. So 1 2 comes out, and 1 3 comes out. The other ones don't make it. 2 times 3 is 6. Isn't that interesting? Let's try that with this 50 over here. 50. We can say that's 5 times 10. 5 is prime, but 10 can be 2 times 5. So we get 2 times 5 times 5. That's all under a square root. 2 doesn't have a partner, but 5 does. So in this group, a 5 gets to make it on the outside, but the 2 has to stay in prison. So the simplified version of the square root of 50 is 5 square roots of 2. So what happens when we change our index to a 3? Let's see what we have. 32 is going to be what? 4 times 8? 4 can be 2 times 2. 8 can be 2 times 4. All these 2's are prime, but 4 is 2 times 2. Now all of these are under a cube root, which means they have to be grouped into 3's, groups of 3. But no matter how many are in a group, only one ever survives. So one of these 2's comes out here on the outside, but since these 2 didn't have 3 in their group, they have to stay inside. And 2 times 2 is 4. So the simplified version is of the cube root of 32 is 2 cube roots of 4. So let's try this 1215. I don't have any idea, I just know 5 works. So that would be 5 times 243. Okay, I know that 3 works, so 5 is prime. This would be 3 times 81. 5 is prime, 3 is prime, 81 is 9 times 9. So we have 5, 3, 3, 3, and 3, 3. Okay, this is a 5th root this time, so now they have to be in groups of 5. 1, 2, 3, 4, 5. There are 5 3's. So in this group, only 1 survives on the outside. This 5 doesn't have 4 more partners, so it has to stay on the inside. So you have 3 5th roots of 5.